This video focuses specifically on the odds ratio. The odds ratio is the probability of success over the probability of failure. Over meaning divide. So probability of success divided by probability of failure. And we've already defined the probability of success as p, some number, some decimal probability between 0 and 1, just like every probability is. And the probability of failure is going to be 1 minus p. So those two things together are going to add up to 1. At the racetrack, you might hear that the odds of a particular horse winning are 1 to 3. That's 1 divided by 3, or the decimal 0.33. And what it means is, for every 1 win, there are 3 losses on average for that horse. So, out of every 4 events, there's 1 win. So the odds ratio is 1 divided by 3, but the probability of success for that horse is 0.25. So what I really want to highlight on this slide is that the odds ratio is not the same as the probability of success. They're very different animals. The probability of success is p. The odds ratio is p over 1 minus p. And we have to sort of get thinking in this way early so that we'll better understand our logistic regression model. So the odds ratio is very different from the probability of success. The odds ratio contains the probability of success, p. Let's think about the odds ratio for a minute on paper. Let's think about a particular event, like being diagnosed with a particular disease. And let's say that we're thinking about that odds ratio, the probability of success over the probability of failure. And we're just going to imagine what that odds ratio would be if the probability of success having this disease would be 0.2. Okay, then that would mean that the probability of failure has to be 0.8 because 1 minus 0.2 is 0.8. So we've got a value of the odds ratio of 1/4 or 0.25 when we had a probability of success of having the disease as 20%, we have an odds ratio of 0.25. Now what I want you to see is that as the probability of success increases, so let's say now that the probability of success is 40%, then the denominator has to decrease because 1 minus 40% is 60%. So we see 0.4 over 0.6, which is going to be 2/3 or 0.67. So when the numerator is increasing, the denominator is forced to decrease, and the overall ratio is increasing. So when we changed from 0.2 to 0.4, the denominator went from 0.8 to 0.6. So if the numerator goes up, the denominator has to go down just because of the way the odds ratio is defined. If the numerator goes up, the value of the odds ratio goes up. If the numerator goes down, the value of the odds ratio goes down. Likewise, if the denominator goes up, this part gets bigger, then the whole thing gets smaller because it's drowning out the size of that numerator. So now think about the odds ratio as just a unit. If the odds ratio gets smaller, it means either that the numerator got smaller or that the denominator got bigger, or both because they're related. If the odds ratio gets larger, like in this case, it means the numerator went up and the denominator went down. So I want you to start thinking about when this thing changes, why did it change? What is the effect in this thing that is created? What is happening? What is the dynamic? So if the odds ratio goes up, it means the probability of success went up. and thereby the probability of failure went down. If the odds ratio goes down, it means the probability of success went down, and thereby the probability of failure went up. Now think about this for a second. In both of these examples, we have the probability of success being smaller than the probability of failure. So take this one step further. Make the probability of success large. Let's say the probability of success is a 0.7. That means the probability of failure would have to be a 0.3. Now, that's going to be a large number. It's going to be 2 1/3. So now you've got an odds ratio that's no longer a decimal. It's larger than 1. So when you see an odds ratio that's larger than 1, it means the probability of success is greater than the probability of failure. Consider also a probability of success of 0.5. Then the probability of failure has to be also 0.5 because they have to add to 1. This is an odds ratio of 1. So what you see over here in these examples, the probability of success is less than a half, and the odds ratio is less than 1. Here, the probability of success is a half, and the odds ratio is 1. Here, the probability of success is bigger than a half. Success is more likely than failure, and the odds ratio is bigger than 1. As the probability of success gets bigger and bigger, the odds ratio will get bigger and bigger also. As the probability of success gets smaller, the odds ratio will get smaller and smaller also. And I invite you to come back to this video as often as necessary just to refresh on this concept because it's the foundation of logistic regression.